Hello again, Sarple Physics here again. Just a quick continuation of what we were just talking about earlier on. Now, we talked about essentially a force that's basically a 10 Newton force acting at 20 degrees to the horizontal. But because the object is moving for a certain distance, 100 meters, that we've assigned ourselves, we need to calculate the work being done. Now, it's very important to basically look at that when you are multiplying work done is force times distance, we are taking the force that is acting in the same direction as the movement of the object. So essentially we are looking at the force that is acting in the x direction, simply because this 10 Newton force can be broken down into the x direction, and also there's one in the y direction as well. And by applying trigonometry, we can see that when you look at this question here, that the work done is going to be the Fx force, the x component force here, multiplied by the distance. Now, when you use your calculations to work this out, essentially what we are doing is that we are looking at the force which is acting in the x direction as 10 cosine 20 degrees, which is then multiplied by the distance 100 meters, as you can see, and the answer is going to give you 939.7 joules of energy. So essentially we are saying that in order for us to move an object by 100 meters, then we need to use 939.7 joules of energy if there's a force of 10 newtons acting at an angle of 20 degrees, but the object is going to move at 100 meters. That's all for now. Please don't forget to subscribe to my Sarple Physics YouTube channel, and I will continue making more clips in the near future.